In order for a chemical reaction to occur, particles have to collide. What that means is they have to hit each other. But of course, not every collision results in a chemical reaction, because the particles have to collide with enough energy in order to react. This is why, even though there is carbon in wood and oxygen in the air, every time a tree goes into the air, it doesn't catch fire. So in order to react, the particles have to collide with each other with enough energy to start the reaction. This energy is called activation energy. Everything is made of multiple particles. This means that the speed or rate of a reaction, which is how quickly the reaction happens, is determined by the number of successful collisions. If there are more collisions in a certain amount of time, more collisions that result in a reaction, then there is a faster rate of reaction. This makes sense, hopefully, meaning that if you have more reactions happening, the reaction will finish more quickly. So the rate of reaction is determined by the number of successful collisions per unit time. This means that we can change certain conditions that the reaction is under in order to increase or decrease the amount of collisions and therefore change the rate of reaction. Remember when you're answering questions about this that it is always going to be about the number of successful collisions. So what can we change? Well, we can change the concentration of our reactants. Concentration is a measurement of how many particles there are in a given unit of volume. If you put more particles into the same volume, then they are more likely to collide. Therefore, increasing concentration increases the rate of reaction because there are more collisions per unit of time. You can think about that as if you put a lot of people into a room, they are more likely to collide into each other when they start running around than if there are fewer people. So what else can we change? Well, we can change the surface area. Surface area is about particle size. If I have a big lump of something, it has a smaller surface area than if I have lots of small lumps. So the biggest surface area is a powder. So surface area is all about the exposed particles. If you increase the surface area of a solid, that means more particles are exposed. That means that there are more collisions. There we go again with the collisions. Therefore, there is a faster rate of reaction. So a larger surface area means a faster rate of reaction. So what else can we change? Well, we can change the temperature. If you think about what temperature actually is, temperature is the movement or kinetic energy of particles. Hot things have faster moving particles, or particles with more energy moving around in them. So if we increase the temperature, the particles will move around more quickly. That means they'll be more likely to collide with each other. Again, imagine if you have some people in a room and they're walking compared to running. If they're running, they're more likely to collide with each other. But there's also something else to add onto temperature as well. If you give them more energy, that means that more of them are going to have an amount of energy that is greater than the activation energy. So to sum that up, increasing temperature increases rate of reaction because it causes more collisions per second as they move around more quickly, and it increases the number of particles with sufficient energy to react. That's only true for temperature. The last thing that you can change in order to increase the rate of reaction is not actually got anything to do with collisions. What you can do is you can add another chemical. And that other chemical is a catalyst. A catalyst is a chemical which speeds up the rate of reaction but is itself not changed at the end of the reaction. So that means you can actually get it back out again at the end. And the way that a catalyst works, it doesn't increase the speed of the particles or increase the collisions. This one is about activation energy. A catalyst works by lowering the activation energy and providing a different pathway for the chemical reaction to occur. So in simple terms, what that means is if you add a catalyst, you lower the activation energy required, therefore it will react more quickly. So that's just a quick rundown of what can affect the rate of reaction. Remember that it's all about collisions and energy. Collisions and activation energy. Next time we will take a look at how to measure rate of reaction. Thanks for watching.